Okay, it's hard to find a humorous image for trace critical minerals. That was as close as I could find. It's mineral water, sir. Of course, there are rocks and sand in it. So maybe sell some for big bucks. Let's see. All right. So this chapter is only concerned four elements, selenium, cadmium, indium, and tellurium. It's, kind of not minerals, not metals that you normally think much about. But there you go.
Also, not
So,
metals you would normally lump together.
yeah, yeah, this is these are together because they have low continental crustal abundances between less than a part per million and down to 10 parts per billion. So it's just essentially not there. These are analytically difficult elements to analyze for. And they, calling them trace um, critical metals is kind of useful because they only occur as trace elements in sulfide minerals. So chalcopyrite, that's a good source of copper because copper is part of the mineral formula. Galena, lead, pyrite, iron, sphalerite, zinc. Those are you know good sources because the metals of dominant interest occur in the formula for the mineral. But these elements only occur as sort of trace elements, remembering Goldschmidt's rules for why some elements are taken up by some minerals and some aren't, and others aren't. So as a result, nobody opens a mine for these elements. These are recovered as byproducts of processing. And that brings up a useful point, which is so many elements, nature isn't as clean as we might like. If you're mining sphalerite, there's going to be other elements in there as well that you don't want to throw away on the tailings pile. You want to separate them if it's economic and sell them as well. But here we can see where indium and tellurium sit on the Canadian strategic elements. And, and here we've got, this is short-term critical DOE, Department of Energy, critical minerals. That's iridium, not indium. So there's tellurium. Yeah, not too many on the United States side. Oh, it says, I say there that U.S. considers indium to be critical, but I don't think that's right. I think I misread iridium, so ignore that because I don't see indium in here. I apologize. But Canada does. All right, so let's take them in order. Let's talk about selenium first. So selenium substitutes for sulfur and sulfide minerals, is mainly extracted as a metallurgical byproduct from refinery anode slimes of primary copper sulfides. So whatever's attracted to the anodes during the, electrostatic separation. The most significant selenium resources are copper-rich VMS type polymetallic mineral systems, which average over 100 parts per million selenium, and some of the hydrothermal black smokers average over 1,000 ppm. So that's useful. Selenium has a wide range of oxidation states from -2 to +6, and so it's going to be redox sensitive. depending on the details of what oxidation state you've got. Selenium is hazardous to human health, and about 50% of all selenium now is produced by China. Now, cadmium is it's only got a +2 oxidation state, and it substitutes for zinc in sphalerite of stratiform SEDEX and VMS deposits. So here we got nice sphalerite and quartz, very pretty. And cadmium is also hazardous to human health. Now, this is an old ad. Here we got that burger will go down smoother with Arden Weenus meat softener, the only cadmium enriched meat softening syrup. So, it sure looks tasty on that burger. You got to admit that green cadmium. And I guess we understand why. Our Arden Weenus's meat softener. I'm not sure I would buy a meat softener from a guy that looked like that, but that's just me. All right, so these are the leading producers of cadmium in 2024, mostly China and a little bit in South Korea, some in Canada, etc. Not a whole lot. Okay, now we get to indium. There's 2 oxidation states of indium. They're +3 and +1. It only occurs as a trace element in sulfide minerals, again in sphalerite. Most indium-bearing sphalerite deposits are VMS type, and indium is non-toxic, thank goodness. So again, China leads the pack. And that takes us, I think, to the last one of tellurium. Tellurium oxidation states are +4 and +6. It also occurs as a trace element in sulfides like pyrite, chalcopyrite, arsenopyrite, and more rarely forming telluride phases such as sylvinocalaverite and krennerite. Never heard of them. Tellurides are mainly rare accessory phases in alkaline rock hosted low sulfidation epithermal gold systems. We'll talk about that some more. Tellurium can only be extracted economically as a byproduct from processing gold or copper gold ores from Carlin type and low sulfidation epithermal gold, porphyry copper gold, or polymetallic VMS systems. And it's mildly toxic. Okay, let's go back one. Let's watch a video. I wonder why it's not showing. I could have sworn I put it in there. And well, so the problem of depletion of resource of these trace elements, cadmium, indium, selenium, and tellurium, and especially indium, are now vital components of solar panels and thus are critical for the renewable energy transition. So producing these depends on mining base metal sulfides such as chalcopyrite, galena, sphalerite, and pyrite, and processing these for base metals such as copper, zinc, and lead. And then you get these other things out of it. So that's an interesting situation of these sort of secondary processing byproducts.